Today we are going to discuss how to prepare calibration standards through a serial dilution. A serial dilution is when you use a concentrated stock solution to create a set of 4 different dilutions. The basic lab equipment you will need will be a volumetric glassware and materials to make calculations. For volumetric glassware, we have a couple different options of a pipetter, graduated cylinder, or a graduated pipette. First, we're going to start out by calculating our standards using V1C1 equals V2C2, where V1 is a volume of concentrated stock solution, C1 is a concentration of the standard, V2 is the final volume, and C2 is desired concentration of your first serial dilution. Using our concentrated stock standard at 1,000 parts per million ammonia, our samples are going to be around 1 part per million, so we are going to bracket our dilutions at 0.1, 1, and 10 parts per million ammonia, with a check standard at 2 parts per million. Using V1C1 equals V2C2, we are going to solve for X here to determine how much concentrated stock solution we will need to make a 100 part per million ammonia standard. Solving for X, we see that we are going to need to take 10 milliliters of 1,000 part per million solution to make 100 milliliters of a 100 part per million solution. Starting with this 100 part per million concentrated solution, we are going to serially dilute down to our 10, 1, and 0.1 part per million calibration solutions. Our calculations should look something like this when we are done. Starting in lab with fresh, clean glassware and our concentrated stock solution, we're going to use a 100 milliliter volumetric flask to perform the 100 part per million dilution. Using a clean beaker, we are going to pour out a small aliquot of our concentrated stock solution at 1,000 parts per million to draw from. You do not want to draw directly from the bottle to avoid possible sources of contamination. Using a 10 milliliter pipetter, we're going to transfer 10 milliliters of that concentrated solution into our clean glassware. Then, using fresh deionized or pure water, we are going to fill the flask all the way to the volumetric line. You want to make sure that the bottom of the meniscus is touching the line so that you truly have 100 milliliters of solution. It can be tricky to pour directly up to the line, so make sure to leave a couple inches of room, and using a pipetter, bring the solution to volume on the flask. Always make sure to use a fresh, clean pipette so you don't contaminate your water source. Once you have completed the solution to volume, seal the flask and invert it to mix the solution completely. Using this 100 part per million solution, we are then going to make our 10 part per million serial dilution. Again, using a fresh, clean beaker, we're going to go ahead and pour out a small volume of the 100 part per million solution so we don't contaminate our batch. You want to make sure as you're making your serial dilutions that you keep your technique consistent throughout. Using the good lab practice of maintaining a clean work environment as well as using clean glassware, it will help reduce contamination of your standards and samples. If you were to contaminate your calibration standards, you may get a faulty reading when trying to calibrate your electrode. The more accurate and contamination-free your calibration standards are, the better the data you will get when you perform your calibrations. It is also a good lab practice to record the date that you open your stock solution, as well as record the date you created your calibration serial dilution. After calibrating the electrode, it is good practice to run a check standard. This will help ensure the calibration was performed accurately and that the electrode is working correctly. Your check standard solution should be somewhere in the mid-range of your calibration curve. Since our samples are around 1 part per million ammonia, we are going to create a check solution at 2 parts per million. The 2 part per million sits right between the 0.1 and 10 part per million calibration standards we created. We are going to use 2 milliliters of the original 100 part per million solution to dilute up 100 milliliters of a 2 part per million calibration check. Running a check solution is a way to validate our previous calibration. If we aren't getting a recovery within 10% of the known concentration, we can go back and assess whether or not the calibration data is valid, whether our serial dilutions have been contaminated, or if we need to go ahead and troubleshoot our electrode. For further help on serial dilutions, please see our application note 001 online at www.thermoscientific.com/water library.